So I'm Marc Pfister. I'm a Python developer over at Maxar, and I work in analytic data products. And come here. There we go. I'm going to take 5 minutes to talk about ARD at Maxar. And when I say ARD, that's kind of the term we latched onto for cloud native geospatial stuff. So we're talking about cogs and stack and things like that. And I was thinking, well, only 5 minutes. I mean, we use it all over the company. So let's do the old journalism trick of just sticking to the 5 Ws of your, your introductory paragraph. So who, what, why, where, and when. And so where, Maxar. So we're ahead of schedule right now. Who is the analytics data product team that I work in. So we create derivatives from our imagery. In a way, we're customers of our own company. We don't sell imagery, we sell things like car counts or building outlines, things like that. And we're a full stack team. We go everything from DevOps to data scientists, front-end developers, technical writers. We essentially function like a small company. And as things are these days, our focus really is using machine learning to generate outputs. And machine learning takes a lot of data, and we have a lot of data because we have about just over 20 years of imagery. We launched our first satellite in 1997. And coming soon in the next year, we're going to be launching a whole new constellation called Worldview Legion. So we're going to be facing even more data that we're going to have to sort of wrangle for our models. And we needed some kind of a solution to make this all work for us. So jumping over to the when, in 2018, we started experimenting with cogs and stack. Just in hackathons, things like that. But for the challenge of working on our big image data sets to feed the machine learning models, we tried to engineer a solution. So we had databases talking to services and all this sort of rigmarole, and we just ended up arguing about how we were going to store things. And we kind of realized after a year of that cog and stack pretty much did 90% of everything we needed to do. So we started making cogs and writing stack for them. It went from a script to a person you had to talk to on Slack to an API. Other teams started looking at it and using it, and it was growing. We were thinking, well, I think our customers could also use this because it was a success for us. It would be successful for customers. But initially, we got some pushback because people would say, don't we already give TIFFs to people? What's going on here? But we'd show them the demos of how teams were using cog and stack to be successful, and it had a schedule and under budget and things like that. So we got it in 2021 finally to be a pilot product. We got enough market interest that it became an official product, and now it's still just growing and growing. We're adding UIs and more tools and more functionality. The what we're delivering specifically that goes to our customers is a trio of cloud optimized geotiffs. So we give you a RGB, pan, and multispectral, a pile of derived masks. This is all gridded to a 5-kilometer UTM grid. You get full stack metadata from your order down to every acquisition, down to each item, which is a tile, and we deliver directly to your S3 or Google or Azure bucket. So it's a full cloud native process front to back. To give a kind of an idea of what we deliver, we write things to this sort of spatiotemporal folder structure where we've got a UTM zone, then a quad key, a date, and then within there you get about 18 files per acquisition. So we have a growing list of masks. You get the stack and all the cogs. I don't have time to go into all that stuff, and this also isn't a sales pitch for our imagery. I want to talk about why cog and stack work great for us, and we think will work great for all of you too. So if you want to look at our sample data, we have it at ard.maxar.com/samples. We're listed in Stack Index if you want to view it from a stack sort of standpoint. We also have extensive documentation about what we're delivering and how you can use it at /docs. So for the why, the two big things are predictability and productivity. So if you're coming from the GIS world, I'm sure you've seen a file like this, or maybe folders full of file like this where you don't know where things came from, what they are, what they represent. We were waiting to face this because, as I said, we have 20 years of image archives, and people would be ordering stuff from different places and putting them here and there and whatever, and things got just completely messy, really fast. So Stack basically gave us all that organization. We didn't have to design a database, the whole things, because Stack already organized it for us. And I had this inspiration at like 4 a.m. this morning that this metadata is the 5 Ws that we're talking about here, where, what, why, where, and when of each image. So we give that to you with the image. You always get it. You don't have to think to remember, hey, did we get the metadata for this file, or where did we get this? It's right there next to the image in that same folder. And these things are all analysis ready. The ecosystem is so good, you can get started on this stuff from day one. And for example, our search system can give you scored images. So if you only can afford or only maybe need 3 images over an area, it'll search the whole catalog and give you the 3 best images. So they may not be all from the same acquisition. So even though this is 3 acquisitions deep, our system gave you 12 different acquisitions to pick the tiles from. And this would be a mess if you tried to keep track of all these things. You know, I'm glad we never got around to finishing our database. And this automatically works in Stack Catalog. So we can see these things, it's organized. It's just such a relief to work with this stuff. Similarly, like with cloud optimized GeoTIFF, like the cloud storage cloud storage is easy for us. We just put everything in S3. It's full stack like our team. There's Python, there's JavaScript, we've got Rust and Golang coming. Every person in our team, no matter what software they worked on, they were ready to work on this. And like I said before, this is, again, analysis ready. We're ready to go to work on this. And an example of that would be, this is our Python SDK. And this is an example of in 5 lines of code of writing a chipper. So you could open up, you know, a huge pile of data in S3 somewhere, open up a GeoJSON file that defines your chip boundaries, and then with 3 lines, you can write those chips out to little chip JPEGs. This is actually the 4th SDK we've written, because the barrier to entry is so low with all the tools we have that every team that started using our ARD tiles would start writing their own SDK from day one. And we've eventually kind of took the best from everything and put it together into the one public-facing SDK that we offer. We often kind of tack how onto the 5 Ws. So if you're interested, we do all our stuff using just Python and then a language called Halide, which is basically a number cruncher for arrays. Could not have done this without the power of the open source community, and there's so many people I want to thank, but especially just the people who've really helped us get going. Chris for taking care of all of this, Vincent for all his work on the cogs, Matthias for Stack, and Daniel for Stack Layer. And of course, like a lot of these we are hiring, so please get in touch with me if you're interested in working on these sorts of things with our satellites.
Awesome. Thanks so much, Mark.